This is the lecture for Chapter 9.1, Estimating a Population Proportion. Make sure you have your note sheets out. Your note sheets is where you're going to take your notes and get the examples down. And so we're looking at this note sheet here. And so this section, Estimating a Population Proportion, we've talked about this before with the idea of something called a point estimate. For example, if I asked you to estimate my age, you would more than likely use a point estimate. It's the value. It's a single value. And what we call a point estimate of a population proportion. If I said what percent of the students in the class believe in aliens, you would give me a point estimate, some proportion, 30%, 40%, 50%, something like that. This is the value of a statistic that estimates the value of a parameter. So you take a sample to get a statistic, and that estimates the value of the parameter, which represents the population. And so we've done this previously. For example, here's the equation for a point estimate for a proportion. And here's an example we could quickly do. Gallup organization conducted a poll in 2013. 10,016 Americans age 18 were asked, do you regard the income tax that you will pay this year as fair? Of those 10,016, 558 said yes. So with that survey, they've obtained a point estimate for the proportion of people in the population who think their tax was fair, and that would be 558 divided by 1016. And then rounding that to 3 decimal places, you get 0.549, or we would say 54.9%. Since this is a sample though, right? This is not exactly going to be the answer for the proportion for the population. It's just an estimate. And that's why we call this a point estimate. In statistics though, we prefer some level of confidence that we know our estimates are correct. In order to do that, what we do is construct something called a confidence interval, an interval estimate. So if I said, guess my age, and you said, instead of giving me a single number, you give me between 40 and 60, you'd be giving me an interval estimate. And so that's what we're talking about on here. And so in this case here, our first definition here goes here in the spot, goes into the empty line right here, and the term is, and I already said it, confidence interval. And again, it's not a complex idea. It's just we start to hear these words and it gets complex. A confidence interval for unknown parameter for some value in the population we don't know consists of an interval of numbers based on a point estimate. So you give some point estimate, and then I think the real answer is between something and something, with the point estimate being in the middle. And then another term we're going to use is the level of confidence. How confident we are with our estimate represents the expected proportion in our intervals that will contain the parameter if a large number of different samples is obtained. And so this idea of doing multiple samples and getting estimates will then help us kind of figure out what the actual value is for the population, what the parameter is for the population. The level of confidence is denoted by 1 minus alpha times 100%. This alpha becomes an important value, which we'll talk about in a little bit. When we give confidence intervals follow a form. To get a confidence interval, it's going to be what's called the point estimate plus or minus what we call the margin of error. That's the form, margin of error. That's the form it takes. So when you give an estimate in some interval, you'll say it's between some number and another number. And the estimate goes in the middle and we'll have some margin of error. And so I want to recall for you, we have our PowerPoint slides that, again, you can review, that I've posted on the website to help you guys that kind of outline some additional stuff from the lecture. And so we've talked about confidence interval, level of confidence. We're going to come back and talk about what alpha means in this case. We'll talk about that. The next thing there is the way we write or the form of a confidence interval. And the next idea is this idea of what we call what is margin of error of a confidence interval. It's that it's a measure of how accurate the point estimate is. So that's the next term we have put in here. The next term we're going to put in here is called margin of error. How far off do you want to be, right? And so we're going to be end up using that. The margin of error depends on 3 factors when we talk about margin of error. And so with those 3 factors, and so how big a margin of error depends on 3 factors: the level of confidence, sample size, and the standard deviation of the population. And so what we have here, level of confidence. So as the level of confidence increases, is in terms of I'm 90% confident, I'm 99% confident. The more confident you are, the margin of error increases. Another factor is sample size, and we've learned that, of course, if we can have a bigger sample size, the more accurate our answers are. And so as the size of the random sample increases, the margin of error decreases. We're more sure of our answer. If we want to increase our confidence, we're not as sure. That's why the error increases. And then another important thing that we've talked about is standard deviation. It's such an important value in statistics of the population. The more spread there is in the population, the wider our confidence interval will be. And so you end up with, again, some estimate and then some lower level of confidence. Your interval is smaller. See, this is a smaller interval. See, it's not as wide. Higher level of confidence has a larger interval, and this is a smaller interval. So keep that in mind there. And so another question is, what does the level of confidence represent? That becomes an important question to be able to answer. So what does it represent? For example, a 95% level of confidence implies that if 100 different confidence intervals are constructed, each based on a different sample from the population, we would expect 95 of the intervals to contain the parameter and 5 not to include the parameter. And so we'll talk more about that, what that means, but we would put this here: if a 95% level of confidence, and alpha is kind of what we're going to call our error. Alpha is that value I said we're going to end up talking about. So I can say construct a 95% confidence interval level of confidence, or 95% level of confidence, or an alpha equals 0.05 level, meaning that I'm allowing a 5% chance. Implies that if we did 100 different samples and created 100 different confidence intervals, that we would expect 95 of those intervals to contain the parameter and 5 not to, meaning that 95 of the intervals would have the value for the population and 5 wouldn't. And so that's an important idea that we'll talk about when we do some problems here. And then to end this introduction here, important to note the shape of the distribution of all possible sample proportions is approximately normal, provided this. So in terms of being able to construct confidence intervals, we have to meet some requirements. We just can't do that. We have to make sure that the sample proportions that we get are approximately normal, right? And that's going to happen when n times p times 1 minus p is greater than 10, and the sample size is no bigger than 5% of the population. And then we have this from chapter 8.2, these ideas that the mean of the sampling distribution of proportions is equal to the population. But these are 2 important conditions that need to be met in order for us to create confidence intervals.